Hello, everyone. I'm Pang Wei, an incoming assistant professor at the University of Washington, and I'd like to tell you about my work on building reliable machine learning models. Today, machine learning systems are widely deployed and deeply embedded into our daily lives. They're used in our phones, like for face recognition. They're on our roads in autonomous vehicles, and they're even in our hospitals, used for diagnosis, early warnings, and treatment recommendations. On the one hand, this is really exciting. There's so much potential across these applications. But on the other hand, it is also extremely risky because these systems have failed and the consequences of their failures are magnified by their reach. For example, face recognition systems have been shown to fail on different demographics, especially minority populations. Autonomous vehicles can fail in challenging environments, such as unfamiliar locations with poor lighting. And medical systems can fail when deployed in different hospitals that use different equipment and have different patient populations. The goal of my research is to make these systems more reliable when deployed in the wild. To that end, I've developed methods for inspecting models to diagnose and better understand their failures. Fundamentally, machine learning models come from their training data, and so we've studied how to trace wrong predictions back to the training data to identify which training examples were responsible. I've also developed interactive systems that can work with human experts so that together they can make more reliable decisions. In addition, I've developed methods for training models to be more robust on minority subpopulations. Typically, models are trained to work well on average, but they might perform poorly on particular subpopulations, as shown here. We've tackled this problem using an approach called distributionally robust optimization, which directly trains models to do well, not just on average, but across many different subpopulations. Beyond developing methods, it's equally important to have good benchmarks for measuring our progress. To that end, my collaborator Sherry and I introduced the WILDS benchmark of real-world distribution shifts last year. This was joint work with many interdisciplinary collaborators, and it consists of 10 datasets across diverse applications that each capture a dataset shift that arises in the wild. For example, training on some hospitals but deploying in a different hospital. And we showed that state-of-the-art methods for handling these shifts basically did not work on the real-world settings in wilds. And so there's a lot more to be done here, both in terms of developing evaluations that are closer to real-world settings and in developing methods that can work reliably in those settings. And I'm excited about pushing on the directions I've discussed, developing better ways to interact with our models, and then using the expert knowledge that we get from that interaction to improve model training and make it more reliable so that we can safely realize the benefits of machine learning systems across all of these applications. Thank you very much.